In this video, we're going to learn about how to implement observability in your Spring Boot applications using Grafana Stack. So in Grafana Stack, we have softwares like Loki, where you can aggregate and index your logs of your application. And then for implementing distributed tracing, we can use Grafana Tempo, which is like a similar software like Zipkin. And finally, we have Prometheus and Grafana, where you can track and scrap your metrics of your applications and then visualize them using Grafana. All right, so now let's start by understanding what exactly is observability. So we can define observability as a process of understanding the internal state of an application through different indicators. So these indicators, we can define them as logs, metrics, and traces. So logs are generally this information you see in your applications, which we write to the standard output, and metrics can be anything which use some measurable information about your applications. So for Java applications, you can consider the JVM information as the metrics, and also the number of threads your application is using and the heap memory statistics. All these come under the metrics our application is going to expose. And finally, we have traces. So this comes along the concept of distributed tracing. So if you have an application A, which is talking to application B, and you want to track the request from start to end, that means starting from the application A, and you want to track the request until application B, you can use something like called as a trace ID, where you can identify the whole path of the request starting from the source until the destination. So for implementing the logging using Grafana Stack, as I mentioned before, we have Loki. So we will see how to implement Loki in our Spring Boot application, and also we're going to scrape the metrics of our Spring Boot application using Prometheus, and then we will use Tempo to manage the traces and to implement distributed tracing. And finally, we are going to use Grafana to visualize and get and bring together all this information and visualize them in Grafana. So let's see the sample we are going to use. So we are going to use a loan processing system. It's a very simple application which consists of two services. One is a loan service and other is a fraud service. The loan service is responsible to accept the request for loan from the customers, and then the loan service will validate this customer against the fraud service, and if the customer is a part of the fraud list, then the loan will be rejected. Right. So this is a simple application setup we are going to use. And then for this application, we are going to implement observability patterns like logging, metrics, and then the traces. So this is how the application architecture looks like on the high level. So you can download the starter code of this loan processing application in the GitHub link. You can find this link in the description section of the video. So this GitHub repository contains two branches. First one is the main branch, which contains the final code of this tutorial. And to follow along this tutorial, you can start from the branch start here. So all you have to do is download this GitHub repository and then go to the start here branch, check out the start here branch, and you are ready to follow this tutorial. So just download this and open it in your favorite IDE. Alright, so once you have opened the starter code in your favorite IDE, so let's go through and make sure that you are in the branch start here. And now let's go through the implementation, like the starter code, and then we will understand how to make our changes to our system to implement the observability patterns. So first of all, we have our root pom.xml. Here we are using the latest Spring Boot version 3.2.0. I'm even using the latest one, the snapshot version, to use some latest feature from the Spring Boot 3.2 version. So in this, you can see that we have two Maven modules, loan service and the fraud detection service. So inside the loan service, if I open the pom.xml, we have the details like we have the Spring Boot web dependency, which helps us to create a REST API, and we have the Spring Boot starter data JDBC dependency. We will use the JDBC. We'll use JDBC to talk to a MySQL database, and then we also have Flyway dependencies where we can run database migrations. Finally, we also have the dependency for MySQL, which helps us to integrate our application with the MySQL database. That's all about the dependencies of this loan service. So now let's go ahead inside the code. I'm going to open source main Java, and let's open the controller. We have a loan controller class, and this loan controller class is exposing two endpoints. The first one is a get endpoint, which is listing all the loans we have in our database, and the second one is the post endpoint, which takes in the request of loan applications from the customers. So if you see the apply loan method here, we are receiving this loan DTO as an input argument for this method, and then we are converting this loan DTO to loan object. We're just doing some normal mapping, simple mapping here, and then we are calling the fraud detection client. So this is nothing but a REST template call. So you can see here that we are receiving a customer ID as an input to this method, and then we are calling the REST template. We are calling the fraud endpoint. So you can see that fraud check, and we are providing the customer ID as a request parameter. And then we are sending the response back as so we are sending the response of the REST template back to the loan service, and you can see that we are receiving the response as a loan status enum. So the request can be either approved or rejected. So if the customer is already part of the fraud list, then we will receive the input as rejected, and if the customer is not part of the fraud list, then we will receive the request and then receive the response as approved, right? So this REST template is defined inside the REST client config class. So if you see here, we are just creating the REST template bean by providing the root URI as the URL of the base URL of the fraud service. So the fraud service is running at the URL http localhost 8081 on the port 8081, and the loan service will be running on the port 8080. So now it's time to check the fraud detection service. So let me go inside the fraud detection service, and also this service is sharing the almost same dependencies here, like starter data JDBC, Spring Boot starter web, Flyway, and also MySQL. So if we go inside the code and go inside the fraud detection controller, you can see that we are exposing an endpoint called as fraud check, and then this takes in the request parameter as the customer ID, which is an int. And if you go inside the fraud detection service class, so we are just doing an exist call to the database by calling the fraud record repository. So let me check so let's go inside the exist by customer method, and here you can see that we are just running a simple SQL statement like a SQL count star from the database for the given customer ID. And if this particular customer exists, then we will get a non-zero value as a response from the SQL query. And the most important thing here is we are using the JDBC client, which is introduced from Spring Boot 3.2. So that's the reason why I wanted to go with the Spring Boot 3.2 version, even though Spring Boot 3.2 is not yet released completely. All right, so now let's go ahead and test both the loan service and fraud detection service together. So I'm going to open the loan service application class, and I'm going to run this application in the debug mode, and I'm also going to do the same thing for the fraud detection service. I'm going to open the fraud detection service application, and then I'm going to run it in the debug mode. So you can see that both the applications are now running. So the fraud detection service, as I said, is running on the port 8081, and the loan service application is running on the port 8080. So now let's open Postman. Alright, so inside Postman, I'm going to make a call to localhost 8080/loan. So this will call the get endpoint of the loan service. So let's make a call. And you can see that we are receiving some test data which I have created. So now let's go ahead and call the post endpoint. That means we are going to call this endpoint to apply for a new loan, and the payload is going to take the customer name, the customer ID, and the amount for the loan and the currency as the input inside the payload. So I'm just going to call this post endpoint, and you can see that we are receiving a response, sorry, your loan was not approved, because this is the customer 101, customer ID 101 is already part of the fraud list. So let's try with another customer ID as 100, and let's try to send this request one more time. And you can see that we are receiving the response, loan applied successfully. Alright, so now let's go ahead and implement the first pattern of observability, that is logging. So we will implement, as I said before, logging using Loki. So the first thing we are going to do is to download Loki to our machine. So in this project, as you can see, we are already using Docker, and we are using Docker Compose to download the MySQL database. So I'm going to add another configuration here to download also Loki as a Docker image. So I'm just going to paste in some code, so which defines a service called as Loki, and I'm going to point this to Docker image of Loki, which is coming from the Grafana project. And I'm also going to define a command where I am defining the config file as the local config.yaml, which is can be found inside the Docker container. And finally, I'm going to define the ports as to run Loki as 3100, and I'm also going to expose the local host 3100 port to access Loki. Right. So once this is done, the next part is to enable our application to send the logs to Loki. So for that, I'm going to open the pom.xml of our loan service, and here I have to add one dependency. To add the dependency, I'm going to open the tech help from the blog post. So this is a companion to this tutorial. So if you are more interested to learn by reading a blog post, you can go through this blog post and read and learn about observability and learn about how to implement observability. So I'm just going to scroll down until I find the section logging, and here you can see that we have the dependency Loki Loki logback appender. So I'm just going to copy this dependency, and I'm going to open IntelliJ, and I'm going to paste this inside the pom.xml of loan service, and also I'm going to paste this inside the pom.xml of fraud detection service. So you can see that the dependency name is Loki logback appender. That means this dependency make use of the logback, which is a logging framework, and it enables us to talk to Loki. The other thing we need to add is a file called as logback.xml. So for that, I'm just going to open source main resources, and I'm going to create a new file called as logback.spring.xml. So this file contains all the configuration on how to structure our logs, and also information about Loki, so that our Spring Boot application can send the logs which it produces to Loki, right? Also for this, we can copy the code from the blog post. So I'm going to open the blog post one more time, and I'm just going to scroll down until I find the section with this name logback spring.xml file, and I'm just going to copy the whole file from here, and I'm going to paste it here. And also make sure that you load the Maven changes if you're using IntelliJ, so that Maven can download the dependency we just added to our pom.xml. So here we have a tag called as appender. Here under the appender tag, you can see that we have a HTTP URL configured. So this is the URL of Loki, where our application is going to push the logs to this endpoint. And finally, we are also going to define the format in which we want to send our logs. So we will add a label for each log by appending some information like the application name, the host name, and also the level of logs we are sending. So by default, we are interested only in the logs with the level as info. So that's why we have defined root level as info, and we are referring to this level using this percentage level expression. So now let's also copy this file from the loan service and paste it inside the source main resources folder of the fraud detection service, because we can exactly use the same configuration and the same file, as there is no main changes we need to do for each service. So after this configuration is done, we are almost ready to check the logs, but we will test all the observability aspects together once we implement each of them. So the next thing we are going to do is to expose the metrics in our services. So for that, the first thing we need is the dependency for Spring Boot actuator, so that we already have this dependency in the starter code. So this is one less thing for us to do. The other thing we have to do is we have to add the dependencies for Micrometer. So that is the library which helps us to gather the metrics and it exposes to Prometheus. So for that, I'm just going to open the blog post one more time, and I'm going to copy the dependencies under the metrics section. So I'm just going to copy the dependency Micrometer registry Prometheus, and I'm going to paste it inside the loan service. So I'm just going to come down and paste this inside the loan service. And also let's do this for the fraud detection service. So after adding this dependency, we need to add some properties to our application.yaml file to describe how to describe the kind of metrics we want to expose. So I'm going to open the source main resources folder, and inside the application.properties file, I'm going to paste in 3 properties. The first one is management endpoints web exposure include. That means we want to define what endpoints we want to expose from our application. So that includes the health endpoint, which decides the health metrics of our application, the info endpoint, which just provides the general information about our application, the metrics, and as well as the Prometheus endpoint. So the Prometheus endpoint is the one which we are most interested in, because this endpoint will structure our metrics, which is understandable by Prometheus. We will see how this endpoints then the response looks like shortly, but just at this point of time, just understand that this particular property will expose all these 4 endpoints from actuator. So the second property we are going to look at is management metrics distribution percentiles histogram. So this is one of the metrics supported by Prometheus, where you can send the metrics in the form of a histogram. So by adding this property, Micrometer will aggregate all the metrics in the form of a histogram, so that Prometheus can scrape this metrics in the form of a histogram. So let's see this with an example. Imagine that you are getting 100 requests to your application, and each request takes some amount of time to respond, right? Like this can be either 0.5 millisecond, like 1 second, or like 1 millisecond or something like that. The response time for each request will be different. So if you want to create the response time metrics, it will be hard to create the metric for each request, especially if your system is receiving multiple requests at a time, right? So for this, you can, instead of creating a normal counter or gauge metrics from Prometheus, you can create a histogram metrics. So an example which how it looks like. Let's see an example for that. So this is an example of how a histogram looks like. right? So imagine that if you are getting 100 or 1000 requests to your system, Micrometer can group all the requests in the form of a histogram, so that it can represent, so that you can put the requests in a specific buckets. So for example, if you take this kind of histogram as an example, maybe one request, so maybe some particular requests are responding within 40 milliseconds, some requests are taking 100 milliseconds, and some requests are taking 140 milliseconds. So this is how Micrometer will group the metrics in the form of a histogram in a predetermined buckets in the form of histograms. Alright, so now let's go back to our project, and I'm going to copy these three properties from loan service into the fraud detection service. So I'm going to open source main resources, application.properties, and I'm going to add this three properties also here. The next part is to install Prometheus in our local machine. So we can do that by going to the Docker Compose file, and here I'm going to again paste this information from the blog post, and you can copy the information about the Docker Compose from the blog post. So I'm just going to copy the Prometheus part from the blog, and I'm going to paste it just below the Loki configuration. So the next step is going to be to add tracing to our application. For that, we need to add two more dependencies to our pom.xml files. So I'm going to open the pom.xml of loan service, and just below the dependency of Micrometer registry Prometheus, I'm going to paste in two more dependencies. You can get them from the blog post, as I mentioned before. So the first one is going to be Micrometer tracing bridge Brave. So this dependency is mainly responsible to enabling tracing with the help of Micrometer in our application. And Micrometer under the hood uses the OpenZipkin Brave project to implement the distributed tracing. So Micrometer is like a facade which has which can have many implementations. So one of them is OpenZipkin Brave. You can also have another implementation called Open Telemetry, which will provide another implementation of the distributed tracing. So in this tutorial, we are going to use the OpenZipkin Brave implementation for distributed tracing. Coming to the next dependency, we have Zipkin Reporter Brave. So this is the dependency which will report the tracing information to Tempo. So the first one dependency creates the traces, and the second dependency actually reports exports the traces to Tempo. Alright, so now let's go ahead and add both these dependencies to the fraud detection service pom.xml. So just below the Micrometer registry Prometheus dependency, I'm going to copy and paste in these two dependencies for tracing, and also make sure to load the Maven changes. Again, if you're an IntelliJ, anytime you make a change to dependency, you have to manually trigger the Maven changes so that Maven will download the dependencies to your machine. The next thing we have to do is to add another property inside our application.properties file. So this property name, you can find it again inside the blog post. So it's called as management tracing sampling probability. So I'm just going to copy it and paste it inside the application properties of loan service, and let's also do this in the fraud detection service. So what this property will do is, by default, Micrometer will only send 10% of the traces to the tracing system. That means to Tempo. So if we just send 10% of the traces, it's not useful for us. So we need to send all the traces which are generated by our applications. So for this, we have added the property tracing sampling probability to 1.0. That means it sends 100% of the traces the application generates. By default, it's just like 0.1. So now we just inverted it and made it 1.0. So after adding this property, both the applications are ready to create the traces information, and the next thing we are going to do is to also trace the calls to the database. So with this configuration, we can add traces to all the outgoing requests from the loan service to the fraud service, because in the background, the REST template is already auto configured to create the traces. But if we want to also add tracing to the database calls, we can do that by adding another dependency. So for that, I'm just going to go back to the blog post, and I'm going to copy the dependency data source Micrometer Spring Boot. So I'm going to just copy that, and I'm going to open the pom.xml of loan service and add it below the Zipkin reporter Brave dependency. And let's do that also for fraud detection service, and import the Maven changes. So after adding this dependency, the next thing we have to do is to create the observation on the code we want to add tracing, right? So by adding these two dependencies, all the outgoing calls through REST template, the tracing information is added to all the outgoing calls for the REST template, because everything is done in the background. But if we want to add the tracing information for the database calls, we have to do this manually by adding an annotation called as observed annotation on top of the repositories. Let's open the repository, our loan repository, and on top of the loan repository class, we can add the observed annotation. So by adding this annotation, all the calls to the database will also have the trace ID, so that we can see the requests to the calls to the database. So after adding this annotation, we also have to create some configuration to enable the observed annotation. So for that, I'm just going to open the config package and create a new class called as observation config. And let's add the configuration annotation on top of the observation config class. And I'm going to create a bean of type observed aspect. Let's call it observed aspect. You can see that I have a GitHub Copilot installed, so it's automatically showing me the recommendations of how this should look like. It's pretty handy. So this observed aspect method takes in the argument called as observation registry, the method argument. So let's call it observation registry, and let's pass this observation registry as a constructor argument for the observed aspect. So after creating this bean, then we are ready to use the observed annotation, and we also need to add another dependency. As you can see that we are using this aspect, which is the term which is used for aspect oriented programming, right? So for this reason, we have to add another dependency to support aspect oriented programming in our project. So for that, I'm going to open the blog post one more time and then copy the Spring Boot Starter AOP dependency here, and I'm going to paste it inside the pom.xml file. Just go inside the loan service, and I'm just going to paste in the Spring Boot Starter AOP dependency. And let's do this also for the fraud detection service, and load the Maven changes. So once the changes are applied, so once Maven has downloaded the required dependency, the last thing we have to do is to copy this observation config class also to the fraud detection service. So inside the source main resources Java folder of fraud detection service, I'm going to create a new class called as observation config, and this goes inside a package called as config. So let's copy the contents of the observation config, so right from the imports to the end of the class, and then paste them inside the fraud detection service. So now we have also the required configuration for the observation as for the observations. So the next thing we have to do is to set up tempo in our machine. So for that, I'm just going to make use of Docker Compose. We can again open the blog post to copy the required configuration for the Docker Compose for tempo. So I'm just going to copy the part for tempo configuration inside the Docker Compose. Go back to IDE, and then under the Prometheus section, under the Prometheus service, I'm just going to paste in the service configuration for tempo. And here you can see that we are using the tempo image from Grafana. The version is 2.2.2, and we are also defining a config file as the tempo.yaml file, which can be found inside the Docker container. So we have to copy the contents of the tempo.yaml file from our local machine. So for that, we have to create a file called as tempo.yaml. So I'm going to do that inside the root project under the Docker folder. I'm going to create a new folder called as tempo, and inside the folder I'm going to create a file called as tempo.yaml, and this file, the contents of this file, also we can find it inside the blog post. Let's open the blog post, and just below the Docker configuration we have the file for tempo. So I'm just going to paste this information inside the project. So this tempo.yaml file has nothing but some configuration to listen, to make tempo listen on the port 3200, and we also have having some configuration to store the trace information inside a temporary folder inside the container. So after adding this necessary configuration, the next thing we can do is to define the ports where tempo can run. So tempo is running by default on the port 3100, and we are exposing it outside on the port 3110. And tempo internally uses Zipkin implementation, so that's why we are also using the 9411 port, which is a default port for Zipkin. So our application, the loan service and the fraud detection service, whenever creates the traces, it will send these traces to Zipkin at the URL 9411. So that's how the traces will be propagated to from our application to tempo. So after adding all these configurations, we have to add another configuration for Prometheus. We've added a configuration file for tempo, but we didn't add it the configuration file for Prometheus. So let's also do that. Under the Docker folder, I'm creating another directory called as Prometheus, and let's add and create a file called prometheus.yaml, and also the contents of the file let's copy from the blog post. So let's scroll up until we go in the metrics section, and in the metrics section, to the end of the metrics section, we have the file prometheus.yaml. Just copy this information and paste it in IntelliJ, and here we have some configuration for Prometheus. So here we have a scrape interval and evaluation interval. So that means we are instructing Prometheus to scrape the Prometheus endpoint for every 2 seconds. You can increase or decrease this interval as you like, and after that we also have to define what to scrape. So for that we have a default job called as Prometheus, which is running at port 9090. This is a default job for each Prometheus configuration, but the main jobs we have created is for the name called as loan service. So this job will scrape for the URL actuator Prometheus from the host of the loans, from the URL of the loan service, as the loan service is running on localhost and our application is not running on the Docker container, right? If you remember, we are Dockerizing all the services, but we are not running our 2 services in Docker. So that's why we have to find a way to provide the IP address or the reference to the host URL instead of the Docker container URL. So when we provide the host name as host.docker.internal, what this will do is it will provide the IP address or the reference of the host to the Docker container, so that the Prometheus, which is running inside a Docker container, can call the application service, call the services which are running on the host machine instead of the Docker. So that's why we added the here. So that's why we added host.docker.internal here, and make sure that you are not using this in production, because usually in the production grade applications we will if you are using Docker, we will also Dockerize our services, right? We will not use this host.docker.internal reference. So similarly, you also have the configuration for the fraud detection service. The path for the metrics is /actuator/Prometheus, and the target is going to be the reference to the local host and the port in which the fraud detection service is running. So after adding all the configuration for Prometheus, the next thing to do is to install Grafana. So we have installed Loki, we've installed Prometheus, we've installed Tempo. We also need to install Grafana so that we can visualize all this information, right? So for that, I'm going to copy the Docker configuration, Docker Compose configuration also for Grafana. So I'm going to go to the section running Grafana, and here I'm going to copy the Docker configuration, Docker Compose configuration, and I'm going to paste this under the Tempo configuration. And here you can see that we are using the image Grafana of the version 10.1.0, and then we are also passing some environment variables. So where we are disabling the authentication, because as we are using this locally, we don't need to log in every time we access Grafana. But if you are using it on production, just don't do this. Always enable authentication on your applications. And the next thing we also have to do is to create the configuration for Grafana. So for that, I'm going to create another folder under the Docker folder called as Grafana. And inside this Grafana folder, we have to create a file called as data sources.yaml because we have to define. So we've installed Grafana. We also have to define what are the data sources we have to visualize inside Grafana. So for that, we created this data source.yaml file, and the configuration for this YAML file can also be found in the blog post. So I'm just going to copy everything here and paste it inside the data sources.yaml file. So we can see that we have three data sources. The first one is Prometheus, which is accessible in the URL, the Prometheus, which is the Docker container name, and the URL as 9090. The second data source is Tempo, and the third data source is Loki to read our log, to visualize our log. So after adding all this information, so that's all we have to do to enable observability and also install the necessary software in our machine using Docker. So let's run the Docker Compose file. So I'm just going to open the terminal and make sure you are under the project Spring Boot, under the root project, and type Docker Compose up -d. So this will start all the Docker containers. I think I didn't start Docker, so also make sure that you have Docker up and running. Alright, so once you have Docker engine up and running, let's go back to the terminal and run the Docker Compose command one more time. And you can see that all the containers are started successfully. If you're running it for the first time, it may take some time to download all the Docker images for Prometheus, Loki, and Tempo and Grafana. So, but eventually all the containers should start successfully. Now let's open Grafana. So for that, I'm just going to go to the URL localhost 3000. So that's where we have configured Grafana to run. So you can see that we have Grafana up and running. So in the homepage of Grafana, just click on this toggle menu and go to Explore. And here you can, under the drop down, you can see configurations for Tempo, Loki, and Prometheus. So let's go to Loki. And if you want to see so you don't find any options because we did not yet start the applications, our two applications. So let's go to the loan service application class and run the application. And let's also do the same thing for the fraud service application. Alright, so once both the applications are up and running, you can already see that there is some information added to our logs. So you can see the trace ID as well as the span ID added to the logs. So this is the distributed tracing, which is in action, which is creating the trace ID and the span ID, and also the fraud detection ID. We can see both the trace ID and span ID, and our applications are up and running. That's good. So now let's open Grafana one more time, and inside Loki, let's refresh. And if you select the label, you can see that we already see the label called as application. And before running the actual request for the logs, so you may have to populate some logs. For this reason, I'm just going to trigger the post endpoint as well as the get endpoint to get some logs up and running. So after we selected the label key as application, we can select the label value as either loan service or the fraud detection service. I will check the logs for loan service and just click on run query. And you can see that we can see all the logs coming from the loan service. We can, when we select the application value as fraud detection service and run query, we can also see that we are seeing the logs from the fraud detection service. So this is for Loki and how to aggregate our application logs using Loki. So let's open Prometheus now so that we can check our metrics. So inside the label filters, I'm just going to select the label key as application and the label value as the loan service. If I want to see the metrics for loan service, I'm just going to run the query, and you can see that in the past 6 hours as I'm working on this application, you see some metrics which are created. If you're running it for the first time, you only see maybe metrics for the last 5 minutes or so, but you can see that we have different kinds of metrics which is captured by Prometheus. And if you want to visualize this metrics, you can also create a dashboard in Grafana. I've already created one tutorials in my microservices series on how to create the dashboard. If you want more explanation on that, you can see the video in the description section. I will link the video in the description section, but all you have to do is to add one dashboard, upload the dashboard to Grafana, and then you can visualize all this information in Grafana. So finally, we are going to check the traces information from tempo. So just in the drop down, select the value tempo, and here we have to provide the trace ID to find out the exact request we want to trace. For that, we can go to our logs and we can get the trace ID information. So I'm just going to copy this trace ID from here and then put it in the trace QL. So I'm just going to select the trace QL section tab under the query type and paste in the trace QL, paste in the trace ID inside the text box, and then press Shift Enter. So here you can see all the calls for the distributed tracing. So for the post endpoint, you can see that the request originated from the loan service, and then the request there was a GET request from loan service to the fraud service, and the fraud detection service received this request, and then it opened a database connection. So this is where our data source Micrometer Spring Boot dependency comes in. So it creates the tracing information also with the database connection. So here you can see that we first initially did a query, select query, and you can also see the information about latency and how the request went through. Finally, we also made another query to the database to aggregate the result set of this query and then return it back to the method, to the application. And we also made one query to the loan service to save this information inside the database, the status of the loan. This is also captured inside the same trace ID. So in this way, you can trace the request end to end from the start to finish using the distributed tracing using Tempo.